morning everyone. I welcome you all in this session. The topic for this session is standalone risk analysis. Though we have seen couple of things about this topic in previous session as well, we will quickly go through those things and then we will look at what are different methods of standalone risk analysis. So, these are two broad categories. You have got analysis of standalone projects and analysis of contextual risk. So, in contextual risk you can have let us say you are analyzing all the projects which are there in that particular firm, and you are also analyzing effect of market forces on those projects, right. If you look at analysis of standalone risk, we have got sensitivity analysis, break-even analysis, simulation analysis, scenario analysis, Hillier model of risk calculation, very important model, and then decision tree analysis, right. So, we will look at these things. In previous class we have also seen a couple of sources of risk. Those are technical, competitive, industry specific, market and international risk, right. All these things we have discussed in previous class, right. When we talked about measures of risk, we did discuss range, standard deviation, coefficient of variation and semi-variance. So, this was our question and we found our final NPV was multiplication of NPV multiplied by probability plus this into this plus this into this. So, that was final NPV, right, and the range was also calculated, right. So, I will show you those values. So, NPV was 540, right. So, this was our final NPV. Range was 700. As I said, range is the difference between maximum and minimum NPV. Standard deviation also we calculated, it was 249.8, right, and variance is just square of standard deviation, right. Now, the other measures which we have seen are, let us say, coefficient of variation, right. Actually the problem with standard deviation is that it is not adjusted for scale. So, what we do to compare two projects, we will take we will calculate coefficient of variation, which is ratio of mean to standard deviation, right. So, NPV of a project is 10, but standard deviation is 4, while NPV of second project is 1 and standard deviation is 4. So, we will calculate coefficient of variation like this. For first it is 4 by 10 and for second it is 1 by 2. So, this is 0.4 and this is 0.5, right. Okay, so let us look at coefficient of variation in our example. To a standard deviation 249.58, 249.8 divided by NPV, which is 0.46, right. So, coefficient of variation for our example is 0.46. Now, the other problem with the standard deviation is that it takes into account all positive and all negative variances, but we are interested in only in negative variance and we want to minimize those negative variances. So, that negative variance is 0.3 into 200 minus 540 whole square and under root of this, right. So, it is 186. We do not want semi variance to be more and more, right, it should be 0, right, preferably. Now, after looking at those measures, let us look at some other methods of measuring risk of standalone projects. So, the second method is sensitivity analysis. Sensitivity analysis is a process of finding change in output whenever we make some changes in input. Why we do so? Because future is very uncertain. We want to know how things will work out if we change some of the things which are there with us, right. So, this is sensitivity analysis. We want to know the effect of input on your final result, right. Let us look at this example. There is a project, investment is 20,000, sales 18,000, variable cost is 66.666% of sales, right. So, just 18,000 multiplied by 0.667, right, you will get 12,000. Fixed cost is 1,000 rupees, depreciation is 2,000 rupees, pre-tax profit is 3,000. Now, how to calculate this pre-tax profit? Pre-tax profit. Pre-tax profit is whatever is your sales, which is 18,000 minus variable cost, or you can do like this also, minus variable cost minus fixed cost minus depreciation, which is 2,000. This comes out to be this 12, 13, 15, right. So, remaining is 3,000, right. So, this is 3,000 and which is given here, right. Pre-tax profit is 3,000, right. So, keep in this formula for calculation of pre-tax profit. Taxes 1,000 rupees, profit after tax is very simple, just subtract taxes from pre-tax profit. So, 3,000 minus 1,000, which is 2,000, right. Cash flow from operations is 4,000, right, and net cash flow is 4,000. So, this question is given to you and you have to calculate NPV, net present value of this project, given salvage value is 0 and cost of capital as 12%, right. You just try this question. I hope all of you would be able to solve. Okay. So, let me also solve this question for you. So, here cash flow from operations is 4,000 rupees. So, this is annuity for next 10 years, right. This is a sequential flow. So, this is an annuity, right, and you know cost of capital 12%, salvage value 0. So, you have got this table, present value of annuity table. So, just look at what is the period, it's 10 years, right. So, look at this particular value 10 years and rate is 12%. So, intersection of these two is 5.65, right. So, NPV is this 20,000, 1,000, we have all these values are again in thousands, right. So, NPV is 26,00,000,000, right. So, this is very simple way of calculating NPV, right. How did you get this 5.65 from this particular table, right. So, 12% and 10th here, right, it is 5.650, right, 5.650, right. Now, this is NPV. Okay. Now, in sensitivity analysis, as I said, we keep we change one of the inputs and we see the effect of that change on output, and here output is nothing but NPV, right. So, if we change sales from 18,000, if we change sales from 18,000 to 15,000, but we keep other important input variables constant, namely investment same 20,000, variable cost 66% of the sales and fixed cost 1,000, right. So, how our NPV will change, right, that is the question. So, you just do one thing, instead of 18,000 write here 15,000, right, and then calculate NPV. Okay. So, for this question these are different outputs, and these outputs I have done in Excel sheet also. So, let me directly go to Excel sheet, then you will understand from where did I get all these NPVs, right. Okay. So, let us move on to Excel sheet. So, this is our Excel sheet and this is our question, right. So, as I said, investment 20,000, sales 18,000, pre-tax profit is 3,000. So, this is pre-tax profit, okay, and NPV is this. So, NPV you can just write a macro over here is equal to NPV 12% and this 4,000 10 times, right. So, you will also get NPV in this way also, right, and NPV for our question is 2601, right. So, let us now perform sensitivity analysis. So, what we have to do? We have to, so in this particular case there are three scenarios given: pessimistic scenario, optimistic scenario and normal scenario or expected scenario, right. Pessimistic scenario means you are assuming that everything will go wrong, everything is against you, right. Optimistic scenario, everything would be positive for your project, right, and expected scenario is normal scenario, right, the way things move normally, right. So, our recent sales is 18,000, right, and let us say if sales comes down to 15,000, what will happen to NPV, right. So, this is our pessimistic scenario and variation in sales is now 15,000, right. Since variation in sales is now 15,000, what would be the variable cost? Since variable cost is 66% of sales, so 15,000 into 0.66. So, you will get triple on this 9999, right, approximately 10,000, right, very simple. Fixed cost, as I said, all other input variables will remain same except sales, right. So, fixed cost is same, depreciation is same, of course, your pre-tax profit will change because your variable cost has come down, right. So, 15,000 minus these three, right. So, 15,000 minus these three, you will get 2001. This is nothing but pre-tax profit when your sales is 15,000, right. Tax is this much, is 666.93. Then profit after tax is very simple, whatever is tax multiplied by tax, subtract tax from pre-tax profit, right. So, you will get profit after tax. Cash flows from operations is also it can be calculated and this is your net cash flow, right, and this value is your final NPV, right, for this particular project. It is minus 1161. So, where this point is written here. So, what is NPV when sales is 15,000 is here, right, this point, right. So, this is the NPV when we changed sales from 18,000 to 15,000. Now, let us see what happens if we change if there is a change in variable cost, right, and let us say change in variable cost is now 70%, right, pessimistic scenario. So, your cost has increased, right. Let us see what happens. So, variation in variable cost. So, say now other things will remain constant, right, other things means sales, investment, right, and fixed cost, right. So, you can easily calculate variable cost is now 70% of the sales, right. In this case it was 66.66, right. Now this is 70%. Fixed cost 1000, depreciation remains same, pre-tax profit is very simple, you can calculate in a way which we calculated earlier, right. Tax is this much, profit after tax 1600, cash flow from operations, net cash flow is this, and this is your NPV 341, right, which is here. Okay. What is the third input variable? Fixed cost. Now let us change fixed cost, right. Now earlier fixed cost was 1000, now it is 1300, right. So how NPV will change because of this? So now sales is same, cost is same, initial variable cost which is 66% of sales, right. All other values you can be calculated easily, and this is your NPV 1471, which is this one, right. So what we have done, we have taken a pessimistic scenario and we calculated our NPVs like this, right. Similarly, if scenario is optimistic, you can calculate NPVs, right. So let us look at just one case of optimistic scenario, right. Now your original in our original problem, sales is this much, right, 18,000, but now scenario is optimistic, right. So sales is now 21,000, right. So this is 21,000, but variable cost will remain same, right. Fixed cost, depreciation, pre-tax profit, tax, profit after tax, and this is your cash flow from operations, and finally this is your NPV 6373, right, this one, isn't it. Similarly for other variables also you can find out NPVs, right. So this is nothing but sensitivity analysis. Now I hope that you would have understood how to do sensitivity analysis. So let me check where these values are there, where these values are in our PPT, right. So this is minus 1161, yeah. So this somewhere here. Right. In fact, these values are exactly correct, right. So just take these values as final values, right. Okay. So let us move on to next analysis. Before going for scenario analysis, let us look at what are the problems and what are the merits of sensitivity analysis. So the merits are, sensitivity analysis will tell you how robust your project is, right, or how vulnerable your project is, because as I said, future is uncertain. If something changes, then your project would be affected, right. So it is good to go for sensitivity analysis a priori, right, before things actually change, right. So it indicates where future work may be done. If NPV is highly sensitive to changes in some factor, it may be worthwhile to explore how the variability of the critical factors may be contained, right. So you know a priori that if sales are coming down, my NPV will be reduced to this much value, right. So you should start working on improving your sales, right. Or let us say if costs are going to increase, then how NPV will come down, right. So it is good to contain costs, right. So you will get an idea and in which areas you are supposed to work to maintain your NPV, right. So, these two are merits of sensitivity analysis, but there are couple of shortcomings as well, right. The most important shortcoming is or limitation is it considers only one variable at a time. So, you can change only one variable at a time and see the effect of that change on your NPV, right. But in real life generally many variables change at a time, and there is interrelationships also amongst those input variables, right. So, that picture cannot be captured through sensitivity analysis. The another shortcoming is subjectivity in interpretation of different projects, right. So, since you have got different projects and let us say due to increase in cost NPV is coming down in one project and in another project also it is coming down. So, there would be lots of subjectivity, right. Shows change in NPV does not show how likely that change would be. Yeah. We really do not know whether that much change in NPV will be there or not. What is the probability of that much decrease or increase in NPV? So, that is another shortcoming of sensitivity analysis, right. So, this was sensitivity analysis. Let us look at another method of analyzing risk in a standalone project, and this method is scenario analysis, right. Now, as we have seen that one of the shortcomings of sensitivity analysis that there we could change only one input variable, right. But in scenario analysis there is a possibility of changing more than one input variables simultaneously, and we will see the effect of those changes on our NPV or whatever is the output, right. If I ask you a question, how many scenarios are possible? So, in previous question also we have seen that there were only 3 scenarios: optimistic, most likely or expected scenario or normal scenario, right, and the third one is pessimistic, right. So, there are only 3 scenarios possible, right. So, we will take of course, you can take an example and you can change your input variables, and you can also see the effect of those changes on output variable, right. So, procedure is there: select the factor around which scenarios will be built, estimate value of each of the variables for each scenario, calculate NPV or IRR or payback period or whatever it is your output, right. Let us look at a couple of merits of scenario analysis. It is better than sensitivity analysis because we can consider many variables, but there are demerits as well. Economic and this is very important point. We think that there are only 3 scenarios, but in real life you will have a combination of them, right. There will be you will have combination of them, you will have interaction amongst them, and there are several possibilities. So, you will not have only these 3 scenarios, right. You will have several scenarios, right. So, you can say that you do not have a discrete scale, right. You can't say that this is optimistic, this pessimistic and this is expected. It is basically a continuous variable, right. So, you have to look this particular demerit very carefully, right. So, let us say for example, if there are 10 inputs and if we take let us say 3 scenarios, right, then the analysis has to estimate 3 into 10 total 30 scenarios, right, because of 10 input variables and you have considered 3 scenarios, right. So, total 30 outputs will be there, right. So, it is difficult to calculate also. Now, let us move on to next method of assessing risk in standalone project, and this is break even analysis. Break even analysis is basically a kind of analysis which gives you a situation where there is no profit and no loss, right. So, it is good to go in that zone where profit occurs, right, because initially what happens, you are investing in a project. After some time, once your product is ready, or if your project is ready, it starts earning, right. So, after some time you will reach at a point where cost is equal to revenue, and that point is known as break even point, right. So, as a manager you should know how much should be produced and sold at a minimum to ensure that project does not lose money, right. So, there are two types of break even analysis. You have got accounting break even analysis and financial break even analysis. Now, when I say accounting break even analysis, I am talking only about accounting profit, right. So, let us take an example where the ratio of variable cost to sales is 0.66. Ratio of variable cost to sales. So, let us say sales is 18,000 and variable cost is 12,000, right. So, this is the ratio of cost to sales. In other words, we can say that for every rupee of sales makes a profit of 0.33. So, when you sell a product of 100 rupees, you would be making 33 rupees profit. That is the meaning of this ratio, right. So, break even analysis, let us for sales is this: fixed cost plus depreciation divided by contribution margin ratio, right. So, what is contribution margin ratio? It is 33.33%, right. And how did we calculate? It's a ratio of variable cost to sales, right. So, fixed cost, and this is the question for which we are finding out accounting break even point, right. So, fixed cost 1000, depreciation 2000, and contribution margin ratio is 0.33, so 9 million. So, when sales is of rupees 9 million, then only you will achieve accounting break even point, right. Now, let us look at financial break even analysis. The focus here is on NPV, not on accounting profit, right. So, you can also calculate what would be the financial break even analysis for sales. In other words, at what point you will get break even point when sales will have certain value, right. For example, in this case, when sales was 9 million, you achieved break even analysis, right. So, in this question, for some other value of sales, you will achieve break even analysis, right. So, let us summarize what we have done so far. In this class, we have seen different methods of project risk analysis. We have seen sensitivity analysis, we have seen scenario analysis, we have seen break even analysis, and in next class we will see some other methods of assessing risk in standalone projects. Thank you very much.